Hi, I'm Peter Hawley, President and CEO of Fabled Copper Corp. And today I would like to tell you about the preliminary cutting-edge underground LIDAR survey conducted in August 22 on our Muskwa copper project. The Muskwa project is comprised of the Neil property, the Toro property, and the Bronson property, all located in northern British Columbia. The original concept and objective of the underground LIDAR survey was to develop and test a workflow process sheet for the use of autonomous UAV systems or mounted systems to create a continuous and update an as-built three-dimensional model of the underground development of the Eagle and Harris veins, specifically levels 6400 and 6950 of the Eagle deposit, using simultaneously localization and mapping, which, if you take each letter of the first, means SLAM, optimization method to create 3D point clouds datasets. A less than 10 centimeter georeference accuracy was accomplished in past process trial runs. The output data will be available in LAS, CSV, or PLY format, and all files georeferenced. The XRN pack and GeoSLAM discovery packs, notebooks, and geometric surveying equipment such as a robotic total field station, YPS backsite, RTK GPS systems, and etc. will be used. From August the 1st to August the 5th, 2022, the College of the North Atlantic's, CNR, and their Office of Applied Research and Innovation, their employees, Blair Brigger, Charlie Dalton, and Dr. Gary Thompson were at Fabled Copper's Muskwa Eagle vein deposit in northern British Columbia. The purpose of this trip was to test whether mobile mapping systems, that's MMS, could be used to generate an accurate georeference dense point cloud of old underground workings. The resulting three-dimensional model will be then used to collect geospatial reference samples for assay, which then could be used to generate a 43101 compliant resource. The MMS used were the GeoSLAM ZEB horizontal and the ENROPAC in both the Eagle vein and the Harris vein. That was the plan, but now the reality. The initial plan was to install control points inside the Eagle vein using traditional surveying techniques and using these control points to georeference the collectible scan data. This proved to be impossible due to ice buildup in the first 100 meters of the adit that reduced the effective height to less than 1.3 meters, whereas the total station used to establish control points requires a minimum of 1.5 meters to operate. So how do we fix this? To overcome this issue, control was established outside the entrance of the Eagle vein and used to georeference the initial scan that subsequent scans would be aligned with during post-processing. The same procedure was applied to the Harris vein. Here you can see the 6400 level portal with the base stations being set up. And here you can see the 6400 level, the start of the LIDAR survey of the adit. Note the resolution of the wooden portal entrance and the definition of the portal base station setup. A total of 913.93 meters horizontally was surveyed on the 6400 level of the Eagle vein. Here is the plan view of the LIDAR on the Eagle vein on the 6400 level. Now, during post-processing, the team encountered some issues when aligning subsequent scans of the Eagle vein to the first georeference scan. The scans were roughly aligned manually in Versus Area 4D software, and fine registration algorithm was run in the same software. It was found that a combination of manual and automated registration was the most effective for this application. While the registration is not perfect, the error observed should not be an issue when identifying coordinates of drill targets. In areas measured, the maximum error was 3.61 centimeters, which was much better than the 10 centimeters previously reported in test runs in other places. Had there been no ice buildup on the interior floor of the mine, a traverse could have been run, placing coordinate points throughout the vein. And this would have greatly improved both the accuracy, if you can imagine that, and efficiency of registration And should the opportunity arise in the future, this method will be used. The Harris vein was able to be completed in one georeference scan, so there are no alignment issues present as can be seen by the high resolution. Look on the left-hand side where I took a shot last year while underground of the Harris. And this was taken at the very end of the audit drift. And on the right-hand side, you'll see the same thing in LIDAR in the pitch black dark. And you can clearly see not only the quartz veining in LIDAR, but also the spray painted stop on the wall. Pretty amazing detail. In preliminary processing, it was found that mineral veins are partly visible in the scans, as you can see. Note the comparison between the photograph and the LIDAR scan at the same location, showing the strike and dip of the mineralization and host rocks. And also, we know the exact GPS coordinate of the area with accuracy of a little over 3 centimeters. Here, the copper-bearing vein is clearly visible on the back or the roof by LIDAR on the 6400 level of the Eagle vein with the exact location of the mineralization plus structures. And remember, an accuracy of 3.61 centimeters. And the mineralized veining continues to be visible on the back or the roof of the 6400 level on this second shot. But as you can see by the GPS coordinates, this location is 248.01 meters east and 172.39 meters north with an elevation change of plus 1.99 meters from the shot I previously described and you saw. Now imagine that, you can be that detailed underground. Just for reference, this is me at the bottom of the ladder on the 6400 level, about to enter the main entrance of the 6400. Note the ladder for reference. This preliminary video clip is part one of 2 parts. And here you start from the outside, and as you can see the base stations, you go down the ladder to where I was standing in the previous photograph, and then you enter the main adit. Note the detail as you zoom along. Oh, here's some low pipes and a few feet of the ice I crawled under, and it just zooms under and keeps on going. You pass by the powder magazine. The intense yellow and green on the roof or the back is semi-massive to massive chalcopyrite mineralization. In closing, using this cutting-edge technology and now having underground 3D point cloud, we can integrate this with the point cloud from the surface UAV drone missions over the Davis Key Eagle vein, plus add the company's 2021 and 2022 sampling results, structural mapping, and geophysics to make one 3-dimensional database. And this will all set the stage for drill targets with accuracy of 3.6 centimeters. The company will keep the shareholders informed as data becomes available. Thank you for watching, and follow us as we explore for fabled green copper in northern British Columbia.